Hello and welcome, physics students. In this video, I want to compare constant velocity to uniform acceleration. As its name implies, constant velocity means the velocity will not change. So if this is a ball rolling across a flat level surface, the velocity stays the same, let's say 3 meters per second, but at each interval of time, the distance also is consistent. So it'll be the same amount of distance in between each of those intervals of time. Whereas uniform acceleration means that the acceleration is occurring. So acceleration is a change in velocity over time, but that it's not changing the rate that it accelerates at. In other words, it's not like a crazy surface that is rolling down, a curved ramp or anything like that. The amount of acceleration that happens in the beginning is the same as the amount of acceleration that happens at the end of the ramp. Therefore, we can say it has a uniform acceleration. In this case, we'll use 3 meters per second every second. All right, in this video, we're going to explore what does that look like in terms of our total time, the velocity at each interval, the acceleration at each interval, and the distance or displacement at each of those intervals. So we're going to take a look at each of those cases, and we're going to talk about that in this video. All right, so let's get to the constant velocity first. I already alluded to this, but in this example, the velocity does not change. And so at the intro, at the very beginning, it's 3 meters per second, and it's going to stay the same at each of the intervals, 3 meters per second, 3 meters per second, and 3 meters per second. What's interesting, though, is what happens to the acceleration, and furthermore, what happens to the displacement or the distance traveled from the time we start the timer. All right, so let's take a look at a graph of that to help us understand conceptually what's going on. I'm going to start with the velocity graph. And here we're said that the velocity is constant. So over each of the times, if I make little ticks of time here, over each of those ticks of time, here's 1, 2, 3, and 4 seconds, the velocity doesn't change. It remains level and constant, and it also is positive. So I'm going to draw a constant velocity as a flat line that looks similar to this. All right, and also because the velocity is not changing, the acceleration actually is 0. So I can draw at the origin my acceleration line. There is no acceleration, either positive or negative, in this example because we're moving at a constant velocity. So I want you to put that in your notes. When there's constant velocity, there is no acceleration. Okay, now I know that means that kind of makes sense, but we're going to compare that to when there is an acceleration in just a minute. All right, so then I can just put zeros for my acceleration along all of these times because there is none, no acceleration. All right, well, how are we going to figure out how far it travels and what would a distance graph look like? We know from our previous lessons that a distance graph will increase at the constant rate. So it's going to have a constant slope, similar to this. And we know it's going to be positive because it's moving away from the origin. All right, but how do we calculate that distance? Well, we can go back to some of our equations, and I'm going to talk about the equations on the right side in a little bit, but I want to zoom in on just the constant velocity equations for a second. Velocity is defined as the displacement over the time, or the distance traveled over the time. I can rearrange that and I can get an equation that looks like this, where the solving for d, I get the displacement is equal to velocity times time. So that each of those intervals, I can plug in the velocity and I can multiply by the time. So that's why I picked some easy numbers for us up here. All right, so let's do the first interval. All right, at 0, we're going to have a displacement traveled of 0 because we're taking velocity times time, so 0. I'm just going to write down the equation underneath here. We're going to do velocity times time. I'm going to do that in each of the cases. So the velocity here is 3, the time is 1, so we've gone 3 meters. The velocity here is 3, and then we've got 2 seconds, so it's 6 meters, and 3 times 3, which would be 9 meters. And you see the pattern. We could keep going on and on. 3 times 4 would be 12 at 4 seconds, and so on and so forth. So when I graph that at 1, 2, 3, 4 seconds, that's what I'm going to be graphing. This will be at 1 second, it will be 3 meters, right here. Then at 2 seconds, it's going to be 6 meters. And at 3 seconds, it's going to be 9. At 4 seconds, it's going to be 12, and so on. That is a consistent slope, and it's going to show me my increasing distance at a consistent rate. That is constant velocity in a nutshell.